the amount of data that needs to be computed to support these use cases is going off the charts. So you need to make sure the technology, whatever you offer, is going to be robust to make sure then, of course, the system stays operational.
This is the podcast for engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. I'm your host, Kelsey Markle, and today we're kicking off a new series called We Power AI. In the next episodes, we'll dive deep into the world of artificial intelligence and how semiconductor technology is helping us meet the ever-increasing demand for it. For this episode, we're joined by the president of our Power and Sensor Systems division, Adam White. Adam, thank you so much for joining us.
Great to be here, Kelsey, and really looking forward to talking about this topic. As you know, Infineon, we cover a broad range of solutions for many applications, but I really feel that AI is a topic of relevance at this time and will continue to be in years to come.
Yeah, that's so true. Everyone's talking about AI with the rise of DALL-E, all of these artificial intelligence imaging tools, and ChatGPT. But why should we really be talking about what's powering AI?
Yeah, okay, great. So let's just maybe start, if I may, at the beginning, right? So really about the use cases of AI. So why is AI so relevant? When you go back and look at this new revolution that is taking place, go back to really what was the last game-changing revolution, probably the internet, many years back. But it took time for the internet to adopt. Now, the difference here with AI, if you look back only a year ago, that actually OpenAI was doing this transformational, once-in-a-lifetime generation change of how we're using this Gen AI to create new use cases. So I'll give you a couple of examples. So for example, natural language processing is one topic that voice processing, for example, can benefit from AI. Image protection, topics right the way through from ADAS, autonomous driving topics, going in now to new topics like AR, VR, and then there's other applications to do with medical industry. There's topics out there now, for example, with financial industries, cybersecurity industry, farming, agriculture. So there's all this abundance of now new use cases coming out with AI. So this now is really, as I mentioned earlier on, once in a lifetime generational shift in the amount of compute power that is required to support those use cases.
Yeah, those use cases require a lot of data, I assume. So that's a lot more processing.
Exactly. Great. And good you bring that up, Kelsey, because actually the data now, the amount of data that we are using has significantly grown. So go back to 2010 to what is projected now in 2025, about 146 fold of data that will be used. Now, that now translates by the year 2025 about 175 gigabytes of data. Now gigabytes. Now I let the audience look up how many zeros are in gigabytes, but there's a lot of zeros in this. And on top of that, the growth now is going to be a compound growth rate of about 30% up until the year 2025. So you can see exactly correct the amount of data that is now needed, whether it's structured data, unstructured data, that needs to be computed to support these use cases is going off the charts.
Right. And I assume processing all this data requires a lot more electricity than before too as well.
Yep, exactly. So today, the amount of electricity supporting this compute, and now let's put compute into the context of data centers. That is today around 1.5% to 2% of the world's electricity that is supporting today the data centers. Now that is equivalent, again, just for the audience here, to approximately the amount of electricity used or consumed in Australia, in some cases up to the level in France. But now if you roll on and you extrapolate the amount of electricity that is going to be needed to support the data centers that ultimately can support the computing power that enables the AI use cases, there is a growth rate anywhere between 3% up to 5 or even 7%. And again, just for the audience's reference, 7% of the world's electricity is equivalent to all of the energy consumed in India.
Wow, and that they have a large population in India, so I guess this makes quite a bit of an environmental impact then as well.
Yep. So again, we got to put that into context because, of course, as we are using and we're consuming all these new AI use cases, and there's been some studies out there that saying between 60 to 70% of the world's population will use AI in the foreseeable future. And so with that, then, of course, we got to keep in context the amount of electricity that's burnt because, of course, it can have an impact on CO2. So let's just give one example for our engineers on listening to this podcast today. If you take the GPT-3, for example, and you look at the large language model training, just for that example, it actually consumes about 1,300 megawatt hours of electricity. That is equivalent to about 200 windmills all working for 1 hour just to train that one model. And then from that actually produces approximately 600 tons of CO2. To be precise, 590 tons from the data that we have recently seen. And on top of that, there was a research now, this is a little bit dated, but back in 2020, the data centers, and this is now before this revolution of AI compute. So the data centers there were having now a CO2 emission footprint of about 330 million tons of CO2 that's generated due to the amount of compute power.
Wow.
So yes, so so the environmental impact is something that we need to understand as users, but more to the point, we're very proud to be supporting then solutions that can, of course, limit and reduce those CO2 footprints.
Do any governments or legislations, are they addressing this impact?
Yeah, so we believe at the moment there is a lot more topics that are now being addressed on this because, again, it's pretty evident the amount of energy that these data centers consume. Legislations are definitely being further discussed, and we welcome that because, of course, there are ideas and solutions that no doubt this series will cover to help these topics to support decarbonization, as well as, of course, not stopping the digitalization of the AI use cases. And there are some examples I was reading the other day about in Ireland. There is now sort of legislations around data centers and sustainable data centers. And I'm very confident there will be more of those discussions taking place.
Oh, great to hear. Great to hear. So it's not about stopping progress, of course. It's about addressing the exponential demand for AI and powering it correctly, right? And energy efficiently.
Yep, perfectly said.
So let's take a step deeper into this. So we are a power semiconductor company. How do power semiconductors play a role in powering artificial intelligence?
Yeah, so I think this podcast was called Powering AI or Power AI. I think we really should be calling it We're Proud to be Powering AI, because as a company that has an abundance of power management semiconductors, of course we then support the areas of decarbonization and enabling digitalization. But in decarbonization, this area of really coming out with the state-of-art semiconductors, we can then quite frankly offer solutions that reduces power losses and of course keeps the performance of the compute power. Now, here, of course, if you think about the more data, the more compute, the more training models, LLMs that you need to be trained, that we can offer now these solutions that can hopefully and will be able to reduce the energy consumption in an efficient manner. And here, as an example, when we now talk about the GPUs, for example, or CPUs, or even TPUs, we can now offer a number of solutions not just on lateral flow, where if you put the solutions actually in a lateral design from a 48 volt right the way into the core, that would produce approximately about 10% power loss. But we've also got, and I believe later on there'll be a deep dive on this topic, about vertical power modules, where you actually put the vertical power modules underneath the processors. And by doing this, you can actually reduce the power losses to less than 2%. So again, we've got these types of solutions that we're very proud of, and that's why I was alluding to, we're very proud of powering AI. We work with a lot of the processor companies in this one example to really offer state-of-the-art solutions.
Okay, so our vertical power modules, among other products that we have, reduce the upfront costs of running data centers to power artificial intelligence. But what about the total cost of ownership? Do our power semiconductors fit into the long-term?
Yeah. Absolutely. And look, and the way that I always answer this question when it comes up is to say, look, if you are paying for electricity, of course, total cost of ownership is very, very important. And you've also got another area that we need to focus on, which is, of course, the CO2, the emissions and the environmental impact. So hopefully less electricity that is used, the less CO2 that can be generated. And then ultimately it's a win-win. So we have proven, and we are working with the world's leading XPU companies out there, where we basically wish to offer the state-of-art solutions, not only to save electricity from the decarbonization perspective, but of course for the total cost of ownership topic as well.
So it's not really an either-or situation, it's a double win.
Exactly.
Great. So now that we've talked about the requirements that artificial intelligence put on semiconductors, maybe we can talk about what our company, Infineon, offers in the realm of artificial intelligence.
Yeah, no problem. So here, I can probably summarize it from grid to core. So we really take and support energy, and even how to generate energy. First of all, whether you're generating it from renewable energy, for example, solar, wind. But then when we actually now take it in from the plug socket, as it were, going into a switch mode power supply.
It's a consumption, yeah.
Consumption of it, of actually then take it into switch mode power supply. That's where we also then have state-of-the-art solutions. Now, Infineon, we're very, again, proud to have three technologies that we can offer in the areas of, for example, switch mode power supply. Now, enabling new topologies like totem pole topologies, we can offer silicon solutions coupled with silicon carbide solutions, coupled with gallium nitride solutions, where you go from this traditional 1 kilowatt power supplies, moving up to the 3 kilowatt, 3.2 to the 5.2 kilowatt, now moving up to the 10 kilowatt and beyond. And what this means is that we want to make sure that we create the power supplies, because you need more power that is generated from these power supplies, but in the same form factor that can fit in the standard racks going in for the data centers, because there's an open compute specifications that needs to be from a density point of view fitted into.
So same size, more power.
Exactly, the density. And here, by using these state-of-art solutions in the switch mode power supply, again, and there's now offerings that we're taking into the market with all three solutions of the technologies, silicon carbide, and GaN, to offer this incredible small, dense solutions going now right up to the 10 kilowatts and beyond.
Okay. I guess our customers have different priorities or different concerns as well, which would make them choose silicon carbide, gallium nitride. Do we take that into account, or what our customers' needs when we develop our products?
Yeah, and that's one of the luxuries of Infineon. So we have all three technologies. So we can actually offer the technologies individually, as it were, into different topologies, into different solutions. But one of the trends that we're seeing now is with a new topology that we can actually use all three technologies in the same solution. So it depends on when you look at the primary side, you look on the secondary side, you look at the LLC, for example. It depends upon exactly how you wish to solve the problem, which topology that you are using, and then we've got all of these technologies that the customers can ultimately choose from. So that's one area. Then if we go from the power supply, we can also then support the motherboard, and then on the motherboard we have lots of topics to do with protection ICs. We have lots of that goes from like the hot swap protection as well as into the E-fuse. We've also got the 48 volt stage 1 or stage 2 or single stage solutions, working with leading edge customers at the moment. And then on top of that, of course, we can support the standard CPUs on the motherboard, but also in the AI acceleration cards, we can again support leading edge solutions for the vertical power module or the down solutions that I was mentioning before.
Okay. Yeah, for the AI card, I remember Optimos is also a solution, right, for AI power card.
Yep, exactly. And we've got one of the world's most advanced silicon MOSFETs, and the teams here at Infineon done an incredible job of developing the one of the best performing Optimos family for the switches. And of course, moving forward, there will also be topics related to gallium nitride in such applications. Some of the benefits, of course, with our FETs, we've also got some of the thinnest FETs in the industry, and from that can also benefit if where you put the FETs in the actual application. So there's all of these benefits that we're seeing, and of course we've got the controller families there, where we've got a very rich heritage of working with the controllers and the power stages over many years in the industry.
Okay, so yeah, we have with our history, we've been able to address the whole system's needs.
Yeah.
That's great.
But I believe and I understand our technical teams will be coming in later in this episode. So I think I'm going to be led off with the major technical details, but I'll leave that to our brilliant, talented team to go through more of those details and exactly how we're addressing these topics of course, efficiency, density, and that drives and supports decarbonization and, of course, total cost of ownership. Now, there's one other topic really relevant, I think, here, Kelsey, I want to bring up is this robustness. Robustness for us is really relevant, not just to us, more to the point to our customers. If you can imagine, you start a training language model, for example, GPT-4. Now, to do LLM GPT-4 training, that actually would need about 80,000 GPUs. Okay, and one of the analysis I read recently was talking about 83,000 GPUs, and that would take a year to train. And that would be many hundreds of millions of dollars of cost associated with that. Yeah. Now, the last thing you want to do is obviously have disruption within the training. So you need to make sure the technology, whatever you offer, is going to be robust to make sure then, of course, the system stays operational. And that's why our solutions are designed to be, of course, the very efficient and performing at the best levels of figure of merit. But at the same area, we want to make sure that they're very robust in the application. And if anybody knows Infineon Technologies, with our rich pedigree of quality, we honor our quality commitments. We've got many years of quality within automotive, for example, very harsh conditions in industrial applications. And of course, we've had many, many years, in fact, nearly 2 decades of history within data centers. And that's why we stand behind our quality. So the robustness is a key area that we also are very proud to support the customers. And I think the customers very much recognize that when they buy Infineon, that they feel that it will work and be of course, very robust in the application.
Right. So you definitely want a technology and products that you can rely on.
Exactly.
Great. Well, yes, like as you mentioned, we'll leave the technical deep dives to our experts. We're really looking forward to that.
Thank goodness.
But thank you so much for being here. Is there anything else that if a listener was just tuning in to the last minute of our episode, any last final words you want to leave them with?
No, I think, look, AI is not just here for today. It's going to be here for many, many years ahead. And as I say, it's transformational. Some will say in the last 30 to 50 years, we've never seen anything so amazing. It's not just adopting, it is exploding in the industry today. We're very proud to be powering that AI with the latest technology solutions related to, of course, energy efficiency. And on top of that, supporting the CO2 and the decarbonization, and not to then conflict with anything related to, of course, total cost of ownership. So here, I'm very happy to hear that you'll be inviting our technical teams. They will do a deep dive into each of the specifics, whether that is on the switch mode power supplies, whether that's on the motherboard, whether it's on the AI accelerators.
Wideband gap, I think.
Wideband gap is going to happen as well to show the different topologies. Exactly, Kelsey. So we're very happy to be demonstrating that. And we look forward to working with the industry and, of course, supporting the use cases of AI, but hopefully in a responsible manner as well by supporting the decarbonization.
Well, thanks again for being here, Adam.
Thank you, Kelsey.
So to our listeners, thanks for tuning in to our episode, our first episode in the We Power AI series. We'd love to hear from you. If you have a burning question or a specific topic you'd like a deep dive on, please send us an email at wepowerai@infineon.com. We'll leave the email address in the description of wherever you're listening to this episode. Thanks again.